Hello everyone, hope that's all of are you good. I'm Sarwar Jony and my student ID is 2217046 and currently I am pursuing my undergraduate degree on Department of Urban and Regional Planning from Khulna University of Engineering and Technology, Khulna. Today we will discuss about normality test in SPSS, IBM SPSS. The software I will use that IBM SPSS, and that will be covered under the Computer Application for Planners 2 course, and course number is 2214. Okay, and let's go to the IBM SPSS. And this is the IBM SPSS, and this is my data set, and I will use the normality test of this data set. Okay, for to check the normality test we will go to just analyze, then descriptive statistics, then explore, and then in dependent list I will just click ace, drag and drop here, and factor list I will just click the class because this has been selected as class as 1 2 3 4. Okay, and now this is being label case, that is not necessary for me. Now I will just go to statistics, and it's a descriptive statistics, yes, and level of confidence mean is 95%. That means significance level is 0.5%. Okay, and I'm using continue, then plot, and here is the factor level together, and stem and leaf to histogram. Okay, I'll just uncheck the stem and leaf to, and this is the transformed or untransformed. I don't want to get transformed right now. I will use transform later. Okay, normalization for normalize the data. Then I am using continue, then option, and exclude the case list wise. Yes, I want to get this list wise, and continue, and there is no change in the bootstrap, and okay, and this is I want to get both display. Okay, if I want I can use only statistics and also plots, but I want to get the both values for me. Okay, and just now I will click okay. Okay, and it's being created, and if I show you that the value has been comes here, and this is the you can say catalog, one kind of catalog. Right now I am using this value for, let's say here is the overall discussion. This is the case processing summary, and there is values are available here, and this is the descriptive. Okay, and this is the descriptive. Here is the confidence level. Okay, 5% trim mean. Okay, and all the data, descriptive data are available here. Is skewness, curtices, maximum, minimum, all value are available here. Okay, then I'm just clicking as, and here is the title. This is the as, and I want to get the histogram. As we can see, this is not normally distributed graph. The first things is more data, and second one is no, and here is that for class 1, for class 2, for class 3, all are not normally distributed. How can we see? Let's we just double click here and enable. Let's enable the values from here. This is the show distribution curve. Okay, and this is the distribution curve. As we see, this is not normally distributed, or this is not perfectly bell shape of this value. Okay, let's see this one. Double click and just click here. This is also not normally distributed, and this is also not normally distributed, right? And just double click, and okay, all of the values are not normally distributed, and this is the values. Let's say the box plot. This is the box plot, and from the box plot we can see the distance of the value is not in same, right? That means this is not a normally distributed curve. That means our value is not normalized value. Now I want to get this value as normalized. Okay, to get this value normalized, we will just go to transform and then compute variable and target variable. I want to get new variable. For this one I'm giving the giving name of the values is normal is, okay, norm is, okay. And now this is the numeric expression. Which kinds of expression I need? I need arithmetic expression. To normalize, we can use various types of formula for max mean, for square root, for logarithm, like that. So we will just use the square root function for normalize the value. I just double click this one, and this is the square root, and in the question mark it says what kinds of value I need. I will just click double is here, okay. When I will click double is here, and it's automatically take the is under square root. And if I just click here OK, it will be work. And square root means this value is 33, and it will cover under square root of it. And now just I am clicking OK, and it's I'm getting this, and this is the normalized value, okay. This is the normalized value we have get already. Let's check the normality of this, the new normalized is. To check the new normalized is, we just go to analyze and descriptive and explore. Here is the values and takes all, and I'm just taking this, double click or just click here. This is the normalized age and class. I'm just clicking the statistics, yes, descriptive, and it's the confidence level is 75. Continue, then plot, and make sure this is checked, because if I want to get the more statistical data, we have to check this normality plot with test, and this is the histogram should be checked, and stem and leaf should be unchecked, okay. And all things will be remain same for this data, and I'm just clicking for both because I need to the both data for statistics and plots. Now I'm just clicking OK, and when I have clicked the OK, this is my data, and this is the my case processing summary. Here is the 100% valid data, there is no missing data here. And now I'm here is the descriptive for the normalized one is, this is the minimum confidence level, then maximum, minimum, median, standard deviation, and range, skewness, kurtosis, all will available here. And this is the normality test, okay. And this is the diagram. As we see, this is the values, and if I want to get is normalized or not, I'm just clicking, double click here and just click the distribution curve, okay. For distribution curve, yes, it's being just like a bell shape. For class 1 it's always normally distributed, and I'm just go to next one and just double click here, and same thing for all, and yes, it seems like just like the bell shape, right? And it's a normally distributed curve, okay. And now this is the QQ plot. QQ plot remains how much differ or how much far the values are from the trend line. This is the trend line, and these values are always near to the line, right? That means this value has been normalized. And this is the QQ plot. This QQ plot remain the average distance from the values. This is the upper values, this is the lower values, this is the negatives, and these are the positive, right? And there's and next this is the box plot. Okay, and this box plot is always almost the middle part of the boxes, right? That means data has been normalized very well. And that was all for today. Thank you. Thanks for watching this video.